Dodging a punch is something we've all wanted to learn. I mean, being able to react in milliseconds to avoid disaster sounds pretty cool, but what if I told you it's something we can all learn? In this video, we'll look at the science behind dodging a punch. Just don't blame me if you couldn't do it, but first, the basics. Reflexes. It's not just about primitive reactions like pulling your hand away from a flame or the hammer at the doctor's office. There are much more complex reflexes that activate entire muscle sequences without your conscious control. We're born with them, but we can also train them. The reflex that allows you to dodge a punch involves a much more sophisticated sensory integration, combining vision, spatial prediction, and muscle movement in fractions of a second. When someone throws a punch at you, it all starts in the eyes, specifically in the motion-sensitive cells in the retina. These cells don't focus on details, but rather on detecting rapid changes in the environment. They detect that something is approaching and send the information through the optic nerve to the primary visual cortex. In less than 120 milliseconds, you know something is moving. To give you some context, reading the word milliseconds takes 400 milliseconds. But here's where something more complex happens. Your brain doesn't just react to the movement, it predicts it. In the parietal lobe, there are neurons capable of anticipating trajectories. This means that while the blow is barely on its way, you're already generating a hypothesis about where it's headed and how fast it will arrive. This predictive mechanism is what allows many fighters to anticipate the movement, even before it fully occurs. They aren't seeing the blow itself, they're reading the intention, literally like observational hacking. At the same time this is happening, the amygdala is activated, not out of fear, but as an alarm center that assesses the level of threat. That signal communicates with the motor cortex and with deep nuclei like the cerebellum, which fine-tune the muscular response. At this point, you haven't made a conscious decision, but your body is already preparing to move, and that seems incredible to me. From the primary motor cortex, a command is sent to the muscles involved in dodging: neck, shoulders, torso, and arms. The total time from when you see the stimulus until your body executes the movement is usually between 250 and 300 milliseconds, but high-performance athletes can respond in less than 150. This reduction is achieved through repeated training, which strengthens the connection between sensory and motor areas, especially through the cerebellum. In other words, they basically reinforce those neural pathways that connect vision to movement, making them twice as fast in these situations. And there's a fact that few people know. Not every motor response has to go through the brain. In extreme cases like an immediate threat, the body can activate what's called a spinal reflex. In this case, the signal travels directly from the spinal cord to the muscle, bypassing the brain. It's an evolutionary shortcut that prioritizes speed over accuracy. This mechanism exists precisely for emergencies where an extra second could make all the difference. Another interesting fact is that the best dodgers aren't necessarily the strongest. Studies in disciplines like boxing and judo have shown that the fastest reaction times are usually found in those with better sensorimotor coordination, not those with greater muscle mass. In other words, good dodging isn't a matter of strength, but of fine-tuned neuromuscular connection. So how do you improve your reflexes? By training 3 things. First, visual perception. Exercises like tracking balls thrown in different directions or using reactive light boards can help you detect faster movements even in your peripheral vision. Second, neuromuscular coordination. Repeating simple dodges in front of a mirror, practicing with a partner, throwing soft punches, or using ropes that hang and move randomly forces you to integrate sight, decision-making, and movement. And third, reaction time. Use reflex apps, games with auditory stimuli, or even unexpected visual cues. The more often you connect your eye, brain, and muscles, the more efficient the circuit becomes. You don't magically react faster, you simply reduce the steps between seeing, processing, and moving. And of course, there are factors that can cause you to fail: fatigue, alcohol, chronic stress, or even overthinking your prefrontal cortex, responsible for rational thought, sometimes interferes instead of helping. You hesitated for a second and it was already too late. But hey, at the end of the day, the best way to dodge a blow is not to be where it's going to land. But if you can't avoid it, make sure your brain has slept well and your body is ready, because nature has already seen your system. All that's left is to train it. Subscribe